So, first thing I want to talk about is what factorization and solving mean. So factorization is just simply where we identify the common factors. Now we're dealing with something like 6y squared plus 3y. That's pretty simple. We can see that we can divide both of those terms by 3y, correct? With these it gets a bit trickier. So more often than not, the way we're going to set these out is to have two brackets. Now what do we do when we've got two brackets multiplying by themselves? What's the strategy we use? Crackball. Go across. I'll write that here so we've got an idea. So we go 1, 2, 3, 4, wouldn't we? Seen that before? And when we do that in collect like terms, how many terms should we have left over? 3, correct? We'll have 4, and then we collect like terms, we'll have 3 left over, correct? How many terms do we have above that bracket? Is that a coincidence? So, once we've done this, we need to identify how can we fill out the unknowns. Now we know there's two x's here. How do we know there's two x's in the first part of that bracket? Jordan, what do you reckon?
X squared.
X squared. The only way I get x squared is when I've got x times x, correct? So that's the only way I can get x squared. So I've already filled out the first part. The next part I want to fill out is the brackets, the sign. When I'm multiplying two numbers together, how do I get a negative?
Positive and negative.
Positive and negative. I don't care which one goes where at this point in time. Now I ask myself, what are the factors of 27? 27 and 1, 3 and 9, correct? Which one of those is separated by 6? 3 and 9. So I know my factors here are 3 and 9. Now I've just got to pick which one's my negative value, which one's my positive value. So which one's negative? Is the bigger one negative or the smaller one? The bigger one. So it should be negative 9 plus 3. I've just factorized. I've just factorized that quadratic, but I have not solved it. So what's the difference between solving and factorizing? What do I have to do now? I have to find out. What do I have to find out? What happened when we graphed it before? What happened when we graphed it before? We're finding the x-intercepts. That occurs when x equals when y equals 0. So what I'm saying is I want this to equal 0. So all I'm finding is my x-intercepts of that function. That's solving. Clear? Now there's only one way that this will equal 0. There's two ways this will equal 0. Either this equals 0 or this equals 0. The null factor law, 0 times anything is 0, correct? So I know now that x plus 3 equals 0 or x minus 9 equals 0. I'll rearrange that to get x by itself. X equals minus 3 or x equals 9. So how would I check that? How would I check that this is where that quadratic equals 0? What could I use? I could sub back in and see what it equals. Even quicker. Grab my calculator out. So I'll be grabbing my calculator out now and writing in x squared minus 6x minus 27 I'll be then hitting shift F5, which is G-solve. Once we've done that, what do we see? When we G-solve, x equals negative 3 and x equals? Is that what we saw or not? Very good. What's different about the next one?
There's a 2 in front of the x.
There's a 2 in front of the x, but because these are all factors of 2, it's actually only one more step. Y equals 2 outside of x squared minus 4x plus 3. What have I done? What have I done then?
Just taking the common.
Taken my common 2 out the front and divided each of these terms by 2. Now I just want to factorise what's in the bracket, so I go by the same steps. 2, I put my x first, identify my symbols. Darcy, what do you reckon my symbols should be? Positive and negative? My hint is look at this one first. How do I get that value? How do I get my second sign? I multiply my two numbers together, which in this case is going to be 2 negatives, because the only way I get a positive is if I've got 2 positives or 2 negatives. Then I look at this one and that tells me that I've definitely got 2 negatives. Cool. And what are my factors of 3? 3 and 1. Now I want to solve it, so what's that mean again? Null factor thing. I want to find out when my function goes to the x intercept, I let y equal 0. Now tell me, what are the scenarios where that could equal 0?
When x equals positive 3 and x.
But yeah, you're right. When that equals 0, will that equal 0, correct? Can 2 ever equal 0? So it doesn't matter. I can divide both sides by 2 straight up. Correct? 0 divided by 2 is 0, correct? So I've still got 0 is equal to x minus 3, x minus 1. I can clearly see now that I've done this a couple of times that x has got to equal 3 or x has got to equal 1. The more you do this, the more fluid it will get. Now what separates this example from the example I gave before which was y equals 2x squared plus 5x minus 12. The difference between this and that is that I can't divide the 5 by 12. So I can't use that first step. Which means now I've got a value at the front. Now if I was really stuck in a calculator exam and I didn't want to think, I could just use my calculator, correct? Or I could use my quadratic, or I could use my bracket still if I wanted to. What's going to change in this scenario? Does x equal x and x here anymore? What am I going to have?
2x.
2x and x, correct? I want to leave that there for you guys to have a crack and see how you go with that. I'm going to do a little bit of talking before I let you go though. The question I'm going to ask you is, can all of these values be solved? Does every quadratic function have 2 intercepts? Let me give you an example. How many intercepts does that one have? How many intercepts does this one have? 1. So a quadratic can have 1, 2, or 0 intercepts. And the way we find out is using our discriminant, which you're going to have to do some reading on tonight to complete your homework, okay? The discriminant might have something to do with the quadratic equation. I don't know, maybe it's the thing that we find inside the square root. I don't know. I'll leave that up for you to figure out. Cool? Have a go at that one, and then I will